thanks. I'm getting the signal that we're going to go ahead and get started. It is 2:30. So thank you guys for coming. I appreciate it. My name is Dave Tashner. I work at Capital One. I'm a senior manager in shared tools. So part of my job is to run the enterprise Jenkins platform for the entirety of the Capital One organization. So what I'm going to talk about today is how you can go through the process of creating a Git repository, multi-branch pipeline in Jenkins, import shared libraries into your Jenkins file, and go through the process of creating sort of a feature branch and then a pull request back into master and go through that whole process. So that's what I'm going to talk about. And I'm just going to dive right into it because I don't have that much time. So the first thing that I'm going to do is I'm going to go ahead and create a new GitHub repository in Capital One's GitHub organization. All right, I'm going to call it Jenkins World. Go ahead and create this guy. Now that I've got my GitHub repo created, I'm going to go ahead and clone it down. Okay, so I've cloned an empty repository. That's good. Now, I'm going to go ahead and move into my new repository. And what I'm going to do is, for the sake of time, I've already created the files that I'm going to need, so I'm just going to paste those in here. So you don't want to see me fumbling around trying to write this thing. So I'm going to go ahead and create the Jenkins file. So let me just walk through this real quick. And it's a little small. Let's see if we can make that a little bit bigger. All right, so I'm going to use the declarative pipeline syntax here. And basically, I'm just saying that I want to run this build on some of our AWS agents. All of our agents are in AWS, actually. The entirety of our Jenkins infrastructure runs in AWS. So I'm going to run this on a regular Linux agent. And then I've defined one stage, and that's just the static analysis stage. This is really just an example to show you how this kind of works. Okay, inside of my static analysis stage, there's a few things that I always like to do in any Jenkins file. I like to return a couple of environment variables from GitHub that are really useful to see sort of in the console output. So I'm actually going to define some environment variables here called get message, get commit, and get author. And that's going to return for me the commit SHA, the name of the person that committed, that kicked off this build, and then the actual get commit message that was included in that commit. And you'll see down here at the bottom on line 27, I'm going to print that metadata into the console output. So I can always sort of refer to that and say, oh, OK, I know the commit SHA that kicked off this build was this, and this is what it was supposed to change. And it's sort of helpful stuff. Then at the very bottom on line 29 and 30, I'm executing a CloudFormation template validation command by calling a shared library. Right, so where I'm calling the shared library is actually right there on line 30. So I don't have to go into each individual Jenkins file that's going to be testing a CloudFormation template and write that logic. I can just use the shared library. So let me go ahead and save this file. That's the entirety of my Jenkins file. It's pretty simple. And let me actually, before I show you the shared library, let me go ahead and create the other files that I'm going to need. So what I'm going to do is make a new directory in my repository for my CloudFormation template. And I'm going to go ahead and create one, just call it test.yaml. And the CloudFormation template that I'm going to be using here is really, really simple. It's just a dummy wait condition handle. It's a valid CloudFormation template, but it's not going to actually do anything. All right, and then, like any good developer, I'm going to go ahead and create a README. Because if you wait until the end of your project to create your documentation is going to be pretty miserable, and your developers are going to have a terrible time trying to write it. So with all of that done, if we look at my git commit, right now I have 3 files. I'm going to go ahead and add these and push those up to GitHub. So now, if we go back to that new repository that I just created, hopefully we're going to see the new files that I need are in there, and they are. So that's good. Now, what I'm going to do is go ahead and set up my webhook to Jenkins, because that's the next thing that I'm going to need. Right? So I'm going to go into the hook section of my repository, and I'm actually going to add a webhook here. I'm not going to use a service hook, because a service hook actually only gets the push event. It's not going to get the pull request event. And I want to test all commits to any individual feature branch, as well as pull requests. So I'm going to set up a webhook. The way that I'm going to do that is by pointing to my Jenkins instance. And this is actually a real Jenkins instance that's in use at Capital One right now. And the webhook URL is just my Jenkins instance / GitHub webhook. All right? And then I'm going to select application JSON as the content type. And then I'm going to select individual events that I want to trigger this webhook. By default, you're going to get the push event. And that's great, but I also want to test pull requests. So I'm going to go in here and select pull requests as well, and then add this webhook. What we should see pretty quickly is that GitHub finds that that's a successful endpoint. It was able to deliver a test payload to that Jenkins instance. So that's great. Now, the next thing that we're going to want to do is actually set up the multi-branch pipeline. And I found that this is the easiest way to get up and running with Jenkins 2. And it's also the most full-featured method of testing every commit to a feature branch and every pull request. So to do this, I'm going to go into Jenkins and click New Item. I'm going to call this multi-branch pipeline Jenkins World, and then go down and select multi-branch pipeline as the job type. All right, now I have a little bit of configuration that I need to do inside of this job, but it's really straightforward. So basically what I have to do is specify my branch source. What is the repository that you want to test? So the first thing I'm going to do is select Capital One's GitHub as opposed to the public internet-facing GitHub. And then the owner is the GitHub organization. That's my EID. And then in the repository dropdown, that's going to be populated with all of the repositories that belong to me, all of the repositories that I have in that GitHub organization. And you're going to see that it already knows about my new repo down here, Jenkins World. So I'm going to go ahead and select that. And then I'm going to go into the advanced configuration and change one thing. I know this might still be a little small, so let me blow that up a bit. I'm going to go ahead and build origin PRs merged with the base branch. So what I want to do is basically make sure that when I create a pull request, what's being tested is the result of what's going to happen when that merge actually occurs, right? So I'm going to actually build pull requests as if they were already merged with the base branch, and that's going to be what Jenkins outputs for me, okay? Then the only other thing that I have to do here is configure my pipeline libraries. Now this is not a necessary part of multi-branch pipeline. This is just something that I'm throwing in here to show you how easy it is to input or import shared libraries from some other Git repo. So I'm going to give it a name, and then I'm going to give it a version. And the version can be a Git tag, it can be a Git branch. And I'm just going to pull the master branch, and I'll show you the shared libraries in just a second. And then I'm going to load these implicitly. I don't want to go in and explicitly have to import libraries in my Jenkins file. I'm just going to make them available to all the Jenkins files in my repository by loading them implicitly. And if you're interested in more of the information on the real technical aspects of the shared libraries, there was a great talk yesterday by Brent Lasser that I would recommend that you look up after this session. It's really good, and it goes into a really low level of detail about shared libraries. All right, so to configure my shared libraries, I need to also provide the branch where they live. So this is also in my organization. So when I go ahead and put that in there, it's going to, again, populate the list of repos with everything that's inside of my org, and I'm going to pull Jenkins World libraries. And that's it. That's all you have to do to configure the multi-branch pipeline. So I'm going to save that configuration. And what's going to happen is Jenkins is going to go up to the configured branch, repository rather, and it's going to look for any branches or pull requests that exist in that repository that have a Jenkins file. And for any branch or pull request that does have a Jenkins file, Jenkins is going to create automatically for us a brand new Jenkins job with the name of that branch or the number of that pull request, and then it's going to run the Jenkins file that it found in that branch. So this is really cool. You can already see that it did that. It found that I have one branch in the upstream repository, and that's called the master branch. And you can see it already created that Jenkins job for me. And if I go into that job, you'll see that it's got my stage, that static analysis stage that I had defined in my Jenkins file, as well as the declarative checkout SCM stage that it just comes with the pipeline declarative syntax. Now, if I go and look at the console output for this job, build number 1, you're going to see that this is the part where I'm going and running those little scripts to return the environment variables that I want for the get message and the author and the commit hash. And then right here is where that metadata is being printed out. So this commit, there's the SHA, was authored by me, and the commit message was initial. So that's great. This is going really well. And then down at the bottom, you're going to see executing CloudFormation validation with shared library. So that's really good as well. It was able to import my shared library, and without me writing any other code in the Jenkins file, it automatically realized that, hey, this repository has a folder called CloudFormation, and inside of that CloudFormation folder, there's a file called test.yaml. Well, I'm going to run CloudFormation validation against that template. And here you can see that it validated CloudFormation test.yaml, and everything looked good. That was a valid CloudFormation template, so the build passed. Now, let me just show you real quick what the shared library looks like. This is the repo where the shared library is. This is, again, really simple. It's just a groovy function, really, that defines where to look for CloudFormation files and then the command to run for any files that you find in that CloudFormation folder that end with star.yaml, and that's it. This isn't really a demo about in-depth shared libraries. This is just a really simple example of how to run them. Okay? So the next thing that you would likely do as part of your development flow, after you've kind of set up your initial continuous integration setup, is you're probably going to start writing features. And so what I'm going to do is go back into my repository here, and I'm going to create a new branch. I'm just going to call this branch Jenkins World. And what I'm going to do is copy that CloudFormation template. I'm just going to create test2.yaml. Obviously, it's going to have the same content, right? But now I have two CloudFormation templates. So when I do get status, it's going to show me that I have this one new file. I'm going to go ahead and add that. Adding second CloudFormation template, right? And then push this up to GitHub. Origin Jenkins world. So if I go back to my Git repo, you're going to see that GitHub knows that I have a new branch. Now, what we'd like to see is that Jenkins also knows that we have this new branch. So let's go back to Jenkins, cross our fingers here. And when you go back to the main multi-branch pipeline job, you're going to see that it did indeed pick up that there is a new branch, and that branch is called Jenkins World. And so Jenkins has automatically created a new job for me with the name of that branch, which is really nice because you can easily identify the status of your builds for every single feature branch, and they never collide with each other because they all have different names. So that's awesome. And then you're going to see that if we go into this job and look at the console output, instead of just testing the one CloudFormation template that's in the master branch, it's actually tested that original CloudFormation template and my new one. So it's actually working exactly the way that I want. So that's awesome. My feature is complete, right? My build has passed. So the next thing that you're going to do is create a pull request. So I'm going to go ahead and do that and add this feature to the master branch. Everything looks good. Now, usually I would go in here and actually write a comment and say, this is the feature that I'm merging, and make sure that all of my other developers on the team understand what the change is that I'm making. But I don't have that much time, so I'm just going to create the pull request. Now, hopefully, Jenkins is going to be aware of this as well, because if you think about when I set up the webhook, I selected pull request events as well as push events. So that pull request event that I just created in GitHub is going to actually trigger Jenkins and say, hey, I'm sending you a payload. This is a type pull request. Jenkins should react to that. And so if we look at this, the multi-branch pipeline is very clear about differentiating branches from pull requests. So if we click on the pull requests tab, you're going to see that Jenkins has automatically created a new job for me with the number of the pull request, so PR1. And if you go back and look at this pull request, this is pull request number 1. It's in the URL, and it's also right here. So that's good. Everything looks good. It also looks like this pull request was successfully built, which is what I would expect. And it validated both of my CloudFormation templates, obviously, because they have the same content. So the pull request looks good. It looks like if I merge this into master, I'm not going to have any collisions. Everything's going to be good. So I'm going to go ahead and merge this PR. And now, I don't need this origin branch anymore. It's been merged into the master branch. I can just delete this, so I'm going to. I'm going to delete this branch. That should also trigger Jenkins. That's another event in GitHub that should be sent over to my Jenkins job. So let's go back to Jenkins here and see what's changed. In the branches tab, you're going to automatically notice that the Jenkins world branch has been struck through. It no longer exists. It's been deleted. So that's good. But it also allows me to go back and look at the history of that branch. So it doesn't just get wiped completely. I can actually go back and see what was my build history. Can I still see all of my previous builds, even though those branches have been deleted? Yes, you can. And if you look at the pull requests tab, you're going to see the same thing. That pull request has been closed. It's no longer open, so it's been struck through. So really, that's the end of the demo. I know it was really fast. I am open for questions, but I kind of just wanted to say that this is a process for creating Jenkins jobs at Capital One that we found to be very easy and extremely helpful in terms of validating every commit that every developer makes to every feature branch. Everything gets tested. And then when we create pull requests, you can have some different logic in there that says, oh, I see this is a pull request. Then I want to go and actually create an integration stack. You don't want to do that necessarily on every commit, but you can do that with pull requests. So, yeah. That's right. So in your Jenkins file, what you can do is when you create a pull request, Jenkins is actually going to expose a new environment variable that only exists on pull request types, and that's called change target. And that's what is the branch that you're trying to merge this pull request into. So you can write logic directly in your Jenkins file that says if change target exists and the branch that you're trying to merge into is master, then take all this other action. If you don't have the change target variable, then don't do anything because it's not a pull request. It's just a commit to a branch. Just run static analysis, for example. Yeah?
Was the difference between the PR build and the branch build that the PR one would merge to master first and then run the build?
It treats it as if it is already merged with the master branch. And there's some logic in the multi-branch pipeline that allows you to more granularly define exactly what you want the properties to be whether you want to build a pull request unmerged with the base branch or whether you want to build a pull request already merged with the base branch. But it doesn't do the merge for you. That's still a human decision to merge the pull request.
Right, but it would merge it in its local game.
Right.
Yeah.
Yep. Yeah.
What kind of checks you're running on the static analysis?
So we do a lot of CloudFormation and a lot of Chef. We also do some Terraform. So usually in the static analysis, and we also have bash scripts like a lot of teams probably do. So we do a number of things. We validate the syntax of the bash scripts. We validate the syntax of our CloudFormation templates. And we run RuboCop and Food Critic against all of our Chef cookbooks to make sure that they're following best practices, that they're syntactically valid, all that sort of stuff, that they're going to be built. Those are our generic static analysis phases that we use for infrastructure development.
Any custom rules that are being run?
We used to have some custom rules that we wrote in RuboCop that have sort of been sunset. We don't really rely on them so much anymore because the requirements that we used to have as a bank have been relaxed in some areas as we've shown that our automation is more mature. Some of those rules have been relaxed, so we don't have to run those rules anymore. But it is easy and possible to create RuboCop rules if you have some Ruby experience. Yeah?
So how much work do you do in your branch build compared to your pull build? In other words, you could do project stuff, you do static analysis, other types of static type.
Yeah. So that's a good question. So in our actual pipelines, usually on every commit we run all the static analysis suites that we have. We also run our security scans. And those are mainly to make sure that our cookbooks are not violating any bad security policies. And so it's a Ruby scanner. And basically what happens is we use Berkshelf to package up all of our cookbooks into tarballs. And then we ship those up to our security scanning application. And that actually happens on every single commit. That's right. So the pull requests always contain 100% of the logic that we have in our every single commit logic, plus some other stuff to actually launch stacks, launch servers, run server spec tests, that sort of thing. Yep. Question? Yeah. The question was, do we have any dashboards that display the status of the branches or the pull requests? Really, right now, it's mostly within this Jenkins job. But we also have built Hygieia. If you might be familiar with Hygieia. It's a DevOps dashboard that's been open sourced by Capital One. And that's able to show some of this information as well. It shows you the status of the last number of builds and that sort of thing. If you want to get some more information about that, there's actually a demo in the expo hall at 4 o'clock about Hygieia. Anything else? Great. Well, I think I'm right at time, so I'm going to go ahead and shut it down. But thank you guys for coming. I really appreciate it.